right? Okay, so sorry. Now, oxidation state where transition metals show a variable oxidation state in its compound, okay, except the first and the last elements. So, in 3D series, so which is the first element in transition series? In 3D series, which is the first transition element and which one is the last? Eh? 3D series, no 3D series, na. 3D means what? First transition series, no? 3D one, that's the first transition series, okay? So, which is the first element? Scandium, and second is, the last one is your, last is zinc, okay? So, except the two, separately also they can show a variable oxidation state. Our question also the layer type of question also transition metal show a variable oxidation state in its compound except the first and the last one. So what is the reason? So okay, and the reason is very simple because of the involvement of your both d electrons and ns electron. You do you know why they involve in the formation of bond molecule as because both have comparable energy. Where energy is almost same. So for that reason, both your d electron n minus one, d electron and ns electron will take part in bond formation, and because of this, they show variable oxidation state. Okay. The next, this is a scandium. So scandium show only +3 oxidation state. Okay. Zinc is showing only +2 oxidation state. Whereas titanium like show got this up +2, +3, +4. Vanadium is showing +2, +3, +4, +5. Manganese they hold this. And then copper also showing 3 oxidation state +1, +2, +3. Okay. Just even volt latest these are the common oxidation state. यहाँ जुन चाहिँ manganese को छ, okay, +7 is also a common oxidation state. Scandium, the zinc it is showing here just one oxidation state, and for scandium it is +2, and for zinc it is scandium को लागि के छ +3, and for zinc it is +2. Now तिम्रो के हुँदैछ भन्दाखेरि so oxidation number show गर्ने जस्तै हेर्दा 3टा छ, then 4टा vanadium ले 4टा oxidation state show गर्दैछ, chromium. So the variable the number of oxidation state that these elements show will increase in this. Kandaki from scandium to manganese. Then again will decrease in this. So manganese the maximum oxidation state show garcha in a 3D series. Okay. So why Bandakiri? Now the maximum oxidation state is equal to what your ns electron plus n minus 1 d unpaired electron. So just the manganese ma ns ma 2 then in and d ma in the 3d ma 5 also. So 2 plus 5 by 7 maximum. Well, from up to manganese. अब जैसे chromium को d ma 5 s ma 1 So when you add the two, you get 6. So maximum oxidation state in chromium is +6. ठीक है सर, तो तिम्रो up to this manganese maximum oxidation state हुन्छ number of electron present in S and unpaired electron present in D orbitals. So minimum oxidation state show गर्छ. Okay, all these are +2 except scandium ले +3. Again, I am repeating. So minimum oxidation state. Okay, so exhibit garcha all transition element +2, but scandium show +3 oxidation state. So can anyone explain why? Scandium ले किन +3 गर्छ किन +2 गर्दैन? Scandium show +3 not +2. Why? Oh, anyone with the answer? Anyone the answer के भयो मुझे question scandium to why it show +3 not +2. So please write down the electronic configuration. You will to answer. From there you will get the answer. Scandium. What is its atomic number? Okay. When you write down the electronic configuration, what is it? 4s2 and 3d1. Okay. So scandium +3. So after losing 3 electron, what is this having? What you can say? Why S+3 exists? Why not S+2? Hmm? Yes. So when scandium, okay, so it shown the +3 oxidation state because in its +3 oxidation state, it acquired the noble gas configuration. बुझेन so त्यसले गर्दाखेरि scandium को के हुन्छ अरे +3 oxidation state मात्रै show गर्छ and not +2. Now next to तिमीहरुको for 3D series oxidation state first increases from scandium to manganese. देखिए ना? Due to increase in the number of unpaired electron and then decreases because pairing take place. Well, iron and nickel. जुन चाहिँ iron and nickel चाहिँ यिनीहरुको minimum oxidation state 0 पनि show गर्छ and it will show in the metal carbonate. So when we go to coordination compound, the metal carbonate के हो so that you able to learn. ठीक है sir? Now next is your stability of higher oxidation state increases in a group from top to bottom. अब हामीले non-transition element में what we have discussed. So if from ongoing down the group, तिम्रो के रे suppose तिम्रो त्यो group ले if it is showing +4 oxidation state +6 oxidation state non-transition element को कुरा गर्दैछु है म. So P block मा. So on moving down the group के हुन्छ भन्दाखेरि तिम्रो higher oxidation state less stable हुँदै जान्छ. Okay, so +6 oxidation state become lesser and lesser stable than +4 on moving down the group. And the reason के थियो? What was the reason? Please listen गरे अलिकति गर्नु न question number something. The energy required to remove why? Because of inert paired effect. सुनेको हैन? So inert paired effect ले गर्दा के हुन्छ भन्दा तिम्रो higher oxidation state less stable हुन्छ because your ns electron जुन चाहिँ छ so that won't urge to take part in the bond formation. So त्यसले गर्दाखेरि lower oxidation state चाहिँ stable हुँदै जान्छ on moving down the group. So transition element को just opposite छ. So तिम्रो higher oxidation state को stability increase हुन्छ on moving down the group from top to bottom. And what is the reason? Because of increase in the distance from the outermost shell. जैसे यता छ तिम्रो molybdenum 4, 6 and tungsten 6 are more stable than chromium. So chromium छ, so then molybdenum, tungsten. So you are moving down the group in the higher oxidation state, that is +6 oxidation state stable हुन्छ. जस्तै chromium at the top, so यसको less stable छ. Okay, and that is why you use potassium dichromate, where the oxidation state of chromium is +6, a strong oxidizing agent, right? Whereas you use molybdenum oxide, where the oxidation state is again +3, right? Tungsten +6, यहाँ पनि +6 छ. And these are stable, whereas this is a strong oxidizing in nature. ठीक है सर? तिमीले स्क्रिन देख्दैछ? तिमीले स्क्रिन देख्दैछ? Okay. Then next is okay, oxidation state of a metal. Yeah, so then next, oxidation state of transition elements differ from each other by unity. जैसे दिमाग को कहते हैं टाइटेनियम शो करते +2 +3 +4, right? So the difference is one only. So whereas in the non-transition element मा के हुन्छ तिम्रो, so non-transition element मा जुन चाहिँ छ oxidation state, so that will be differed by 2 units. जस्तै +4 +6 त्यसरी के गर्छ oxidation state show गर्छ. Again, so transition element ma jun chai oxidation state ko difference sa, okay, it is by unit only, one unit, whereas for non-transition elements it is by +2 unit, right? And next just the oxidation state of a metal in solvent depend गर्छ तिम्रो nature of solvent का. जैसे copper +1 oxidation state in aqueous solution is unstable, right? And it undergoes disproportionation reaction. जैसे copper ion will change to copper +2 ion and copper solid. Okay, now this is disproportionation. What is disproportionation reaction? So in disproportionation reaction, so the same element will get oxidized, same element will get reduced. So copper ion in the aqueous solution na पहिले पनि C plus हुँदैन, Cu plus हुँदैन, so it will change to Cu plus 2. So Cu plus 2 in aqueous solution is more stable than Cu plus. Then next तिमीहरुको low oxidation state हरु जस्तै अघि नै भने तिमीहरुको iron र nickel ले zero oxidation state show गर्छ in carbonyl. Now this is CO. Why भन्दाखेरि यो जुन चाहिँ carbonyl छ, so in your complex compound, so next chapter we will discuss. So these are the ligand, okay, and these are pi acid ligand ones. So what is pi acid ligand and all, so that we are going to discuss in the next chapter. So it is the nickel and iron. So lowest oxidation state, that is 0, okay, with carbonyl, as because these are the pi acceptor, this ligand have the pi acceptor character in addition to sigma bonding. Now again from this video in the next chapter we are going to discuss. So transition metals ratio was the highest oxidation state with chlorine and oxygen. Himalaya oxygen and chlorine the highest oxidation show for metals. Why? Because they have small size and they have very high electronegativity. Just say in fluoride, very higher oxidation state achieved with the TiX4 the +4 the +5 chromium +6 manganese +7 तर show MnO3 the oxygen with fluorine. अब तिमीहरुको fluorine को किन oxidation state, why it stabilize the highest oxidation state in metal भन्दा, it's because of in case of your cobalt trifluoride lattice and enthalpy highest हुन्छ, and for your vanadium pentafluoride and chromium hexafluoride because of higher bond enthalpy. Okay, so these fluorine can stabilize the maximum or highest oxidation state of the element. Now chromium को oxidation state of +6, for vanadium +5 and cobalt को +3. Again, transition metal they show us the highest oxidation state in fluorine and oxygen. So questions are, name a transition element which does not exhibit variable oxidation state. Answer me. So kunchi transition or transition element, okay, which does not exhibit higher oxidation state or variable oxidation state. Iron and nickel? No. No. और मैले अघि प्रश्न मैले डिस्कस गरिसकेँ transition element which does not show or transition element which does not show variable oxidation or sorry yes variable oxidation state. It's scandium. Okay, a transition element which does not exhibit various oxidation state is scandium. Okay. Now next up, which of the 3D series of the transition metals exhibits the largest number of oxidation state and why? Again 3D series ma largest number of oxidation state kalle show garcha and why? Hmm? So 3D series को elements मला बताओ तो what are the 3D series elements? Name the 3D series element. First is yes. Then mm, mm, mm. And the answer is manganese. Okay, sir. Okay, scandium, vanadium, titanium, chromium, manganese. Where? So, so manganese show maximum number of manganese show variable largest number of oxidation state, and the reason is maximum number of unpaired electrons. Correct, Alicia. Okay. Now next again it's a transition element which does not exhibit variable oxidation state is scandium, and the 3D series in 3D series the manganese show largest number of oxidation state, and the reason is it contains highest number of unpaired electron, largest number. Now your friend in Mn plus 2 M reduction potential role. Right? So the electrode potential depends on hydration enthalpy, ionization enthalpy, sum of first ionization enthalpy, second ionization enthalpy, and it depends on sublimation enthalpy. Now this is the trend of your electrode potential with the atomic number, increase in the atomic number. Okay, so which red one is the observed one, where black check calculated value. So there is a up to iron observed and calculated value. Okay, same sir, but from you this cobalt, the nickel, this copper, zinc. Right? Okay, so yeah, there is large variation, difference. Now, what is the reason for irregularity? I would say it's not a simple trend, right? So there is large of irregularities at increase by decrease by increase by decrease, increase by increase and decrease. So what is the reason for irregularity? Actually, it's in the main depends on ionization and enthalpy, and we know across the period ionization and enthalpy changes, so that changes, so that is again irregular. Where the again irregularity in variation of electrode potential is because of irregular variation of ionization and enthalpies, and because of hydration enthalpy. Again, difference hydration enthalpy for divalent ions, right, of these elements. Now next, जो जसको यता नेगेटिभ छ जस्तै यो 0 भयो, सो 0 नेगेटिभ कसको छ, तिम्रो प्राय सबैको नेगेटिभ छ एक्सेप्ट योर कपर. कपरको जुन चाहिँ इलेक्ट्रोड पोटेन्शियलको भ्यालु पोजिटिभ छ है, 0 लाई क्रस गरेर माथि गएको छ, कपरको भ्यालु पोजिटिभ छ. जो जसको नेगेटिभ भ्यालु छ, okay, that act as strong reducing agent र यसले लिबरेट गर्छ हाइड्रोजन फ्रम डाइल्युट एसिड. जैसे तिम्रो जिंक प्लस HCl गर्दा यु गेट जिंक क्लोराइड प्लस हाइड्रोजन ग्यास हैन. आयरन सल्फेट सरी आयरन प्लस सल्फ्युरिक एसिड गर्दा अगेन आयरन यु डिस्प्लेस गरिदिन्छ हाइड्रोजन, यु गेट हाइड्रोजन ग्यास. कपरले मात्रै के गर्दैन डिस्प्लेस गर्दैन सो तिमीले त्यो पहिल्यै सानो क्लासेसमै गर्दै आएको छ ओके नाउ बिकज अफ योर why कपरले गर्दैन बिकज अफ पोजिटिभ इलेक्ट्रोड पोटेन्शियल अफ कपर ठिकै छ जो जो एलिमेन्ट छ त्यसको नेगेटिभ रिडक्सन पोटेन्शियल छ र जसको छ that will act as the reducing agent and liberate hydrogen from dilute acid. Then copper को liberate गर्दैन why because of its positive electrode potential. Now question answer why copper have positive electrode potential. Another anyone why copper have positive electrode potential again तिमीले के गर्नु पर्यो so draw the electronic configuration copper को so copper plus 2 को पूरा होगा copper to copper plus 2 have positive electrode potential and the question is question 1 so copper 29 electronic configuration 4s1 3d10 okay so copper 2 cu plus 2 plus then cu plus 2 so दुईटा इलेक्ट्रोन successively remove बस एउटा एउटा so copper के electronic configuration 4s1 3d10 when it loses one electron okay so 4 as 0 हुन्छ then 3d10 which is completely filled okay filled and stable र के भयो 4 as 0 र 3d9 after losing it so यहाँ जुन चाहिँ use गर्नुहुन्छ this is ionization enthalpy 1 okay and this is ionization enthalpy 2 जुन चाहिँ second ionization enthalpy so that is very high why because to remove second electron is very difficult as because second electron has to remove from the stable retained configuration okay sir so again so जुन चाहिँ छ यो copper यसको के छ so जुन चाहिँ electrode potential छ from E so Cu plus 2 to Cu okay this is positive and the reason is because sum of your first and second ionization enthalpy is very large okay again sum of a copper which is not balanced by hydration it is larger than the hydration enthalpy so because of that copper will have positive electrode potential. Now next so the values of reduction potential for manganese, zinc and nickel are more negative than expected. What is the reason? Copper को positive छ तिम्रो जुन चाहिँ manganese, nickel and zinc को it is more negative than expected. जस्तै the nickel को छ this is the expected value right? Sorry, calculated value use the observed to be more negative. So this is also uncalculated one. Calculated one to more negative. Why? Again, so use the nickel, zinc, manganese, use the values is more negative than expected. Copper को positive था. I have explained you why. Now question is why these three elements have more negative electrode potential, standard electrode potential than the expected one. Try करें notes electronic configuration lekha, then try to answer. तुम्हारा game answer करो. Maximum time you need to write down the electronic configuration. Answer my relay for me too. Vanata, what is the reason? Let this session be more interactive, please. Yes. Mm. Electronic configuration. Lecture opinion electronic electronic configuration. See, check. My answer will be able to you just cross check it with the answer is correct. Write out the electronic configuration. My object factor focus like Mn, Cu, then Cu plus and Cu plus 2. This is Mn plus 2. Here and C. Mm. 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 Okay, very good. So for zinc and manganese, you know the body structure because we're writing the electronic configuration only, and for nickel, you yaad rakhna, it is because of the hydration, large or highest negative enthalpy of hydration for your nickel plus 2 ion. अब ये से value जरूर है तुम्हारा देखो, अब ये से याद रखना, okay? The electronic configuration is easily body structure, but for this we need to know the hydration enthalpy value. Now next is questions. So why is the highest oxidation state of a metal exhibited in its oxide or fluoride only? Again, why is the highest oxidation state of a metal exhibited in its oxide or fluoride only? Okay, then we'll move to the next. Alicia, try to answer. Martha join one. Alicia listening. Try to answer on the answer please of you. Zina. Yes, and yes. Okay, chlorine or oxygen because of small size and because of the high negativity. Very good. Okay. Now next is which is a stronger reducing agent, chromium plus 2 ion or Fe plus 2 and why? So reducing stronger reducing agent whatever see the one which easily loses electron. Okay, so out of chromium the iron which easily loses electron and why? Question simple sir. So reduce stronger reducing means which easily loses electrons. So chromium or iron. So for this again you need to write down the electronic configuration. So chromium then chromium plus 2 plus 2, then chromium plus 3 multiply. Easily lose this means plus 2 to plus 3 easily change over. For chromium, electronic configuration is 4s1 3d5. When it loses 2 electrons, 3d into 4 into the when it loses 1 electron, it will change to configuration 3d3. Now you identification now. Then for iron Fe plus 2. Then easily electron use गरेर it has to convert to plus 3. So when you write down the electronic configuration, this is 4s2 3d6. When it loses electron delta 4s0 and 3d6 huncha. When it again loses 1 electron 3d5 huncha. Okay. ठीक है सर आपको मैले 5 भने so iron ले easily electron lose गर्छ भन्दैछ so iron is stronger reducing, but here chromium is okay strong reducing in nature as because after losing 1 electron it is having D3 configuration. Again this D3 configuration is very stable after configuration. ठीक है सर. So when we again coordination ra yo ekdam neatly bhayera huncha, but mo यो chapter सकेर मात्रै I'll go to coordination chemistry. So in coordination chemistry जुन चाहिँ तिमीहरुको d orbital, so this is how we are drawing. So why we are drawing like this, because it represents that all the d orbital have same energy, right? अहिलेसम्म हामीले यो बनाउँदैछ. So, but when we go to coordination chemistry, that we will learn about the new thing like splitting of d orbital. Right? So, the d orbital will split when it forms complexes into two. Right? So, one is your P2G set, P2G set banja र अर्कोलाई भन्छ EG set. Okay, so you have back number चाहिँ तिमीलाई डिटेलमा पढाइदिन्छु. Now P2G we know अब D मा के छ भन्दाखेरि पाँचवटा अर्बिटल छ D X Y D Y Z D Z X D X square Y square र D Z square. Right? Now this X Y Y Z र Z X theta, so this will form P2G set. And the dx square y square dz square, it will form EG set. So this is your dx square y square and dz square. Now you think that d dx y dy z and dz x. Now the relative so d after losing 1 electron. So chromium is having d3 configuration. So first according to Hunt's law of multiplicity, the first singly fills up then only the pairing will occur. So when you write down the electronic configuration for Cr plus P, so this is the configuration. But P2 is used to label, sir. So this is half filled, okay, and this is stable. So answer is in your okay. So out of Cr and chromium and iron, so which Cr plus 2 and Cr plus Fe plus 2, which is more reducing color. The answer is your Cr plus 2, and the reason is after losing 1 electron, it will have D3 configuration or stable P2G3 configuration. P2G that theta electron. Understood? बुझ्यो कि बुझेन? Okay. So for answer, what is the answer? Yes, and the reason? Half year P2G3 configuration. P2G3 configuration. So it is this answer is there in NCERT book. But electronic configuration you need to write down your C. Every time when you are answering questions, either structure draw wherever applicable, right? Either you draw structure or write down the electronic configuration. Let me what Himali, write down the electronic configuration or 2-3 sentence probably with only the full marks. So Jan science यहाँ से लिखने लेखा तुम्हारा. Last question था. Why is the E naught value for Mn plus 3 to Mn plus 2 proper much more positive than for this chromium plus 3 ion or U? You भी चला तो तुम्हारे लिए ही सब कुछ था. Now you can see chromium plus 2 dp plus 3 U easily electron निकाली आ रही है पहले negative का. तो plus 2 dp plus 3 easily electron निकाल सकते हैं. Iron में तुम्हें है ना F plus 2 ion also after losing one electron it will give D5 configuration of this one which is stable. Okay, now for manganese plus 2 to plus 3 means its value is positive Y. Again write down the electronic configuration. Write down the electronic configuration. Here is तुम्हारी vehicle software को छाप. Mn teacher, then you just write what is Mn plus 2 then Mn plus 2. Manganese over here 4s0 3d sorry manganese 4s2 and 3d 5 right and the Mn plus 2 here 4s0 and 3d 5 okay sir. So now to lose electron from d5 configuration is very difficult or easy. Why? Configuration. So to remove electron from stable half-wave configuration is very difficult. So for that reason, you can say something low. Ionization enthalpy for this Mn or what we can say is I1. You just put ionization enthalpy is very large for manganese and for that region. So this half value, this is E0 for values are okay more positive than for chromium and for Fe plus 3 to plus 2 ion. Understood? You plus 3 to plus 2 will obviously is okay with the D3 configuration as the E and for iron you look at the configuration D5 is the for manganese you will electron become for a D5 which is very difficult. मुझे सपने now next one now magnetic properties. Okay sir, so you know paramagnetic property diamagnetic property है ना. So paramagnetic property के लिए बढ़ता है. What is the reason for paramagnetic nature? So these transition elements are paramagnetic in nature. What is the reason? Transition to paramagnetic is a property is because of presence of unpaired electron and diamagnetic is because of all paired electrons. The question is why transition elements are paramagnetic in nature? D को कभी कभी रखा हुआ scandium 1 को कितना D1 यानी कि vanadium को कितना D2 यानी कि manganese को कितना D5. So they contain what one? unpaired electron okay na n minus 1 दिला because of presence of unpaired electron in transition elements, they are paramagnetic in nature. The unpaired electron कहाँ हुन्छ? So that again you need to mention. Right? So n minus 1 d unpaired electrons, the orbital number. N minus 1 d orbitals number, or you can write this n minus 1 d unpaired electrons. Now paramagnetic nature of substance, okay, that is characterized by magnetic moment and which is calculated by spin only formula. Okay, so mu is equal to root over of n plus 2, where n is your number of unpaired electrons. Number of unpaired electrons. Okay, for scandium. कति हुन्छ ल scandium plus 3 के भन्छ ओके रेडियो okay for manganese Mn plus 2 can you calculate this mu value you do the spin only one magnetic moment transition elements are paramagnetic nature, that is to your value measured also by spin only magnetic moment, which is mu equal to root over of n plus 2, where n is number of unpaired electrons. So for manganese, what is the number of unpaired electrons? Manganese iron particular number of unpaired electrons 5. So what is the value then? Mu को value हुन्छ okay root over of 5 plus 2 Bohr magnetron okay so what is 5 into 5 plus 2 means 7 what is root over of 35. What is the value of root over of 35? Root over of 36 what is yes, root over of 36 is 6. But this is root over of 5 into 5.9 something Bohr magnetron concept. ठीक है सर? Okay, so तुम्हारा ये mu को value पे वाला सोचे and mu को value देखो जा, then you need to find is the number of electron present, unpaired electron present. So calculate the magnetic moment of a divalent ion in aqueous solution. Iron को निकाला ला magnetic moment. Then what is the oxidation state? And if atomic number of iron is your 26. So, तिमीलाई question मा भनेकै छ divalent भनेर. भनेपछि what is the oxidation state of iron in this case? Divalent means plus 2. Okay, so plus 2 now what would be the electronic configuration? The iron is your 4s2 3b6 Fe plus 2 भनेपछि 4s0 3b6 so n निकाला what is the number of unpaired electrons then you can easily calculate magnetic moment and it is equal to root over of n plus 2 so what is the number of unpaired electrons here? Yes, it is 4. So what is that? Root over of 4 into 6. What is that? Root over of 24. 25 to what is? Root over 25 is 5. So root over of 24 what is that? 4.9 something Bohr magnetron. Okay, so this is how you calculate magnetic moment of divalent. So तुम्हारा question में आउंगा. So why is the transition elements or its compound paramagnetic in nature? And the reason is very simple, because of presence of n-1 d unpaired electrons. So कोही magnetic moment calculate so this is how you have to do. Okay. The next is formation of sulfate, so what is the color? Copper sulfate will be formed of which is blue, and potassium permanganate, तिमीले ल्याबमा युज गरेको छ टाइट्रेसनमा what is the color? Violet, pink भन्छ हैन. त्यहाँदेखि पोटेशियम डाइक्रोमेट को orange छ, iron sulfate pale green छ. Okay, so maximum type of zinc को मात्रै तिम्रो white and zinc oxide कुरा गरे zinc sulfide all in white and किन भन्दा तिम्रो क्वेशन सोध्छ तिमीले आन्सर पनि भन्छ. So transition elements and ions are colored. So your reason because of your presence of unpaired electron. Right? Unpaired electron means र अब अर्को अझै एउटा कुरा आउँछ allow DD transition पनि हुनु पर्यो then only the compound becomes colored. अब मैले अघि भने जुन चाहिँ D orbital छ so when it form complexes or when we go to the coordination compound हामीले भन्छ D orbital छ so त्यसको energy के छैन same छैन but later it will split into two half. One is T2Z half and another one is EG. Right? T2Z label हुन्छ र EG label हुन्छ. अब के हुन्छ भन्दा सपोज तिम्रो यता इलेक्ट्रोन अनपेड इलेक्ट्रोन छ हैन. अब के हुन सक्छ भन्दाखेरि now there is a gap. So your transition हुन सक्छ from T2Z to after absorbing energy from visible region it will okay excite me to the higher EG state. So right so जुन चाहिँ excitation छ or जुन चाहिँ इलेक्ट्रोनहरु जम्प गर्छ EG देखि T2Z देखि EG या EG देखि T2Z. So this is what we call DD transition. So तिम्रो जुन पनि transition elements छ यो colored छ so एउटा त unpaired electron मात्र हुनु परेन भएन. So unpaired along with unpaired electron there must be allowed DD transition. So sometimes तिम्रो के हुन्छ भन्दाखेरि so एउटा दुईटा तीनटा पाँचवटा केसमा के हुन्छ so all will be happening हैन. अब तिम्रो इलेक्ट्रोन यहाँ देखि यहाँ दो it contains 5 unpaired electron तर के हुन्छ इलेक्ट्रोन आफै जम्प गर्नुको लागि T2Z देखि EG so जम्प गर्दा it will have same spin दुईटाको spin same छ है. अब यो जानुको लागि एकदम हाई एनर्जी चाहिन्छ किनभने एक्साइट हुनु पर्यो एट द सेम टाइम यसको स्पिन रोटेसन पनि हुनु पर्यो. ओके त्यसले गर्दाखेरि इन सच केसेस यो युजुअली कलर देखिँदैन कम्पाउन्ड. सो त्यसले गर्दाखेरि formation of color compound is because of unpaired electron at the same time allowed DD transition. बुझ्यो सबैले? So why transition elements are colored? Because of presence of unpaired electron and allowed DD transition. Okay, sir. Now, the तिम्रो complexly your usually when transition elements so that will form complex compound. तिमीले बादमा हाल्नु जान्छ. अघि एउटा complex compound थियो iron को Fe then H2O6 okay plus 2. So के छ तिम्रो अन्त अझै यो iron को complex कार्बोनिल वाला FeCO6 वाला जति पनि this complex transition elements त्यसले complex compound form गर्छ. बादमा तिमी देख्छौ तिमीले next chapter मा reason के हो भनेर सोध्छ. Okay, now reason is one it have comparatively smaller size of because of the comparatively smaller size of alkaline. अर्को छ vacant d orbitals हरु हुन्छ भयो which is available for bond formation. र तिनीहरुको high charge density हुन्छ. Okay, तिनीहरुको के हुन्छ high charge density. यो र यो माथि the same. So तीनटा reasonले गर्दा they form complex. One is they have comparatively small size of the because of the comparatively small size of metal ions. Next is vacant or the availability of vacant d orbital for bond formation and because of their high charge density. This is the reason why your transition element form complex compound. Okay, so this topic we are going to discuss later. Okay, sir. So, Malay, now you again answer. So, what is the reason? Okay, so what is the reason for scandium? So, we name the elements from previous series which show maximum oxidation state. First question, scandium. Right. Here, manganese.